Hello everyone, can you hear me? How's the sound today? So Dr. Gay is traveling, as she may have told you yesterday. She's on her way to Australia. Hello, hello, hello. A little bit low, better? Hello, 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 better? I increased the volume. Okay, let's see. All right. Hello, Susie, Larry, Hani. So yes, I was saying Pamela is traveling. She's in Australia. She's gonna give a lot of awesome talks. She's a great speaker, and I'm gonna cover for her today. So let's start officially. Hello everyone, and welcome to the Daily Space for Thursday, October 4th of 2018. And we're here to bring you the news in space and astronomy. Today we have two main stories. We're going to talk about planetary systems. One of the most exciting stories that I heard yesterday was the possible discovery of an exomoon, the first exomoon. It's not confirmed yet, but it could be. And the story goes that this scientist using the Kepler Space Telescope and then they did a follow-up with the Hubble Space Telescope. They have found evidence that there could be for what could be the first discovery of a moon orbiting a planet outside of our solar system. So this is this candidate, this moon candidate. It's in a system that is about 8,000 light years away from the Earth in the Cygnus constellation. Is orbiting a gas giant planet that in turn orbits a star that is called Kepler 1625. Um, Somebody's telling me that the sound is still not good. I'm gonna increase the level. Hello, better? Hello, hello. Better sound or not? I'm using a different microphone here. So I'm gonna try to speak up again. Luckily, there's no one in the office, so that's good. Anyhow, so I was telling you, this is a system that is orbiting a star called Kepler 1625. And this is an example of how these two NASA missions have worked together to try to figure out what's going on. This would be a very remarkable discovery. Um, because, well, we know that the moons outside our solar system, we don't have the technology to image them directly. And their presence is inferred when they pass in front of a star. And then you're using the good old transit method, you know. So then you have the star that is passing in front of, I'm sorry, the planet that is passing in front of a star, and then you measure what you call the light curve, and then you're going to hope to see a dip in the light that you get from the star that is going to tell you information about the planet. So uh, such an event is called a transit, as I said, and it has been used to detect a lot of the exoplanets that we have found up to date of the order of 4,000 or so. Well, and then as I was saying, exomoons, of course, are harder to detect than exoplanets because they are smaller than their companion planet. And so their transit signal is weaker when you plot them on the when you try to look at these transit at these light curves. And at the same time, the exomoons also shift the position with each transit, of course, because they're orbiting the planet itself. So that these kind of things makes it a little bit harder to identify this type of moons outside of our solar system. So the astronomers in this study, they're astronomers from Columbia University in New York, and they analyzed data from about 284 Kepler discovered planets that were in more or less wide orbits that they had like more than 30 days around their host stars. And then they saw that this particular star, this particular planet, Kepler 1625b, after the star, had some anomalies in its light curve. And then what they saw, actually, what were these anomalies? There were these little deviations or wobbles in the light curve that caught their attention. So they found this planet with Kepler, and then they went to the Hubble Space Telescope, and they spent about 40 hours making observations with Hubble to try to confirm that these anomalies were actually there. And they were still using the transit method, of course. So they were able to obtain more precise data on these dips of light, and they actually monitored the planet before and after the transit of the planet of the star. So after the transit ended, the Hubble detected a second and much smaller decrease in the star's brightness approximately 3.5 hours later. And that was an indication of the little moon actually following the big planet, like in the same way like a pet is following a master or something like that, of course. And then when I say little moon, and this is another interesting thing, is that it's not actually little. It's actually of the size of about Neptune, the moon. And astronomers think that actually the planet has the size of several times Jupiter. So, well, so that was one thing. So, but in addition to this extra dip of light, then Hubble provided more supporting evidence for the moon hypothesis by finding the planet transit occurring more than an hour earlier than predicted. So, based on calculations, if the planet did not have any moon, then the researchers thought that it would be observed at a certain point in time. But then they actually found that the planet actually transited and 1 hour earlier than they expected. And this was indicated, this is consistent with the hypothesis of the planet having another moon and these two bodies actually orbiting their common center of mass. So that could be one explanation, but then in their paper, the scientists also say that it could be that there is another larger planet that is actually perturbing the system and that is causing this delay, although they have not found any evidence for the existence of this other type of planet. So, well, in the end, they say that a companion moon is the simplest and most natural explanation for this second dip in the light curve and the orbit timing deviation. And it was definitely a shocking moment for the astronomers to see in this light curve taken by Hubble to see how you find this second anomaly at this second dip. So this another thing that the scientists were able to measure was actually the percentage of mass of the companion planet. So they were able to estimate that the percentage of mass with respect to the companion planet was about only 1.5% of the mass of the whole planet. And as I mentioned before, this is a planet that has an estimated mass of about several times the mass of Jupiter. So they point out that this mass ratio is actually similar to the one between the Earth and the Moon. But in the solar system, in the case, for example, of the Earth and the Moon or the Pluto Charon system, we think that the moons actually were formed after a collision of these rocky bodies. Some asteroid actually hit, for example, the Earth, and then after all that debris that was left, then you find that then the moon actually was formed. But in this case, in the case of this planet, the Kepler 1625b, actually we have gas planets. So it's not actually clear how this moon could have formed. It could be that maybe it was just captured by some, just by gravity or, well, who knows? So it's likely that the mechanism was different from the formation of the moons in the rocky planets of the solar system. So yeah, so well, in the future, of course, we're gonna keep looking with Kepler. We have tests. One of the things that we want to do is to be able to use a space telescope in order to find more exoplanets. So we're hoping, for example, to use WFIRST. WFIRST hopefully will happen. It was suggested to be canceled by the presidential budget, but hopefully it will actually happen. And one of the potentials of WFIRST is to finding more than an order of magnitude more of planets, but using a slightly different technique, using gravitational lensing. But hopefully, we will be able to find other types of planets with other types of exomoon using this type of facilities. And then, of course, before the W1st, we also have the James Webb Space Telescope that will be able actually to find, to help us find a lot of candidate moons around other planets. So James Webb is actually going to happen. It's been delayed, but it's actually going to happen, and hopefully W1st will happen as well. And yeah, so that was the first story of the day. And for the second story of the day, we're going to keep talking about planets, but this time we're going to talk about our own solar system. And this is also another important discovery because astronomers from the Carnegie Institute and from the Northwestern Institute in Arizona and the University of Hawaii, they have used the Subaru, the hypersuprime camera in the Subaru telescope to find another minor planet in what they call the inner Oort cloud in our solar system. So they have found this object. It's a very, they call it a very remote ice ball in the solar system, very far away. And how far away? It is about 80 times the distance from the Earth to the Sun, or about 80 astronomical units. And it takes about 40,000 years for this object to orbit the Sun just once. And something that is also interesting is that the very existence of this object actually points in a figurative way and in a literal way to another major planet in the solar system that may exist in the solar system, that it could be planet 9. But this is a planet that has been theorized but hasn't been found yet. So this is a discovery, as I said. This is an object that is about 80. The distance is about the distance from the sun of this object is about 80 astronomical units. Just to give a context, the distance of Pluto, the mean distance of Pluto is about 35 astronomical units from the sun. So this is an object that is about 2.5 times further away from the sun than Pluto is right now. And the researchers point out actually that this is an object that is, it could be pretty much anywhere in the sky, and is very faint. So it was very fundamental that we were able to use a wide field camera with hundreds of millions of pixels, such as the hypersuprime camera. And it's one of the best facilities that we could use. Another facility, another optical camera, is the dark energy camera in the southern hemisphere in Chile. So astronomers, they estimate that because of the brightness of this object, that it is about 300 kilometers across. So it would be categorized as a dwarf planet. And yeah, I mean, the orbit is very, very elliptical. It's about 0.9, very close to 1, 0.945. It means that it's a very elliptical object. And just to remember, the eccentricity is just a number between 0 and 1 that tells us how elliptical a circle is. So an eccentricity of 0 is just a circle, and then if you go to 1, then you have a parabola. You don't have an ellipse anymore. And then one of the cool images that I wanted to show you is actually, if you look at your screen right now, you're gonna see the differential image of the discovery of the planet. So this is an image taken. This is a pair of images taken 3 hours apart with a hypersuprime camera, and you can see how actually astronomers are able to find this type of objects. They just take a lot of images of the same part of the sky, and then after doing a lot of data reduction, a lot of data cleaning, then you should be able to match all the background stars that are very, very far away, and those stars should not move in that relatively short period of time. And then you're just looking for the little dot that is moving. So with our eyes, with our human brains, it's easy. This is what you can see. It is way harder to just tell a computer to actually help us to find this type of differential objects. So yeah, I mean, this is a very important discovery because, as I said, it is pointing us to also towards the existence of another hypothetical planet called Planet 9. So this is a trans-Neptunian object. It is, as I said, located in what is called the inner Oort cloud. And one of the cool things is that if you plot the orbit of this planet, so The image that I just showed before, this is another interesting fact. This image was taken in 2015 actually, but then it took the astronomers another 3 years actually of more observations to be able to confirm that they were actually finding another object, another dwarf planet in the solar system. So they were able to figure out the hypothetical orbit of this planet. And the thing is that if we back up a little bit, the orbits in the planets in the in the solar system, in what we know like the four rocky planets, the four giant ice gas planets in the solar system, according to the theories of the formation of the solar system that we know, they all should be orbiting in more or less in a plane, which is what we observe. But then if we go farther the Kuiper belt, and then we go up to the Oort cloud, which could be like a 1 light year away, then you would expect that these objects actually have orbits that are pointing anywhere, that they are pointing in random directions, and they shouldn't be pointing anywhere because there is no actually dominant force of actually gravity making them point in a particular place in space. What researchers have found in the previous years is that we don't know a lot of objects over there, you know, in the inner Oort cloud. But for the objects that we have found, like Sedna, for example, and this planet that we just found that they actually nicknamed the Goblin, the planet that we're talking about, they are able to plot their orbits, and they see that their orbits actually are not pointing in random directions. They're actually aligned in a preferential direction. And this gives evidence and it gives weight to the hypothesis that there might be another object actually with about 10 times the mass of our Earth, that it could be due to the gravity of this object. Then you find the particular orbits of these other objects. So this hypothetical planet has been called Planet 9, or some other people call it Planet X, and we're still looking for it. And actually, probably these researchers were actually looking for Planet 9 when they found this new planet, this Goblin planet. So, yeah. So there are a lot of surveys that a lot of astronomers are actually using telescopes in Hawaii, in Mauna Kea, like this one, the Hypersuprime camera, the Subaru telescope, and the Hypersuprime camera. The researchers at Caltech have access to the Keck telescope. There's some researchers of the universities of California. And then there are other surveys, such as the Dark Energy Survey, or even the Hypersuprime camera survey, that are still, even though they were not designed to find objects in the solar system, this type of surveys can be used to try to find for these type of objects. So this is very exciting, and then we're waiting to see if we actually find another planet in the outskirts of the solar system, which would be very exciting news. So I'm gonna go back and then read the comments that you may have, and answer any questions that you may have. And so Larry's asking, with respect to the first story, what are the period of their orbits? So let's go back to the image, and I believe that their periods of the orbits is of the order of days, of tens of days. I don't have the exact number, but the researchers were looking at orbits that were kind of far from the star, so in a way it would be easier to find an Exo Moon. And these orbits actually taking of the order of more than 30 days is what they say. How far is the system from the parent star? Yeah, that's a good question. And I don't have the exact answer for that, but I'm pretty sure that if we look at the paper, we should be able to figure it out. I'm trying to see if I can find the paper. I found the other paper about the Goblin planet. So maybe let me look it up later, and then I can come back to you. I don't have actually the distance of the moon to the planet. I'm sorry, of the system to the host star. would a moon this large affect the planet's weather, or is still too small? Well, the ratio between the planet and the actual moon is similar to the ratio of the masses between the Earth and our own moon. So maybe not the weather per se, but of course we know that the moon affects the Earth through the tidal forces. So there's definitely a way that a chance that a system that has this ratio of masses could be they could be influencing each other in the same way as the Earth moons actually affect the tides in our own planet. Larry says perturbing planets is a good name for a band. Yes. Jupiter has a lot of moons. Would a moon this large actually clear out the rest of the system? Yes, that's a possibility, and that's definitely an option, and one of the things that I'm pretty sure the scientists are asking right now. And then, as I said, this is like a different type of moon. It's a moon made of gas. It's not like the other moons that we have in our solar system, although like in the rocky solar system. But of course, in Jupiter and Saturn, we have a lot of variety of moons, moons with atmosphere, or even with the liquid methane or stuff like that. And it's definitely possible that a moon this size could be actually clearing out in a gravitational way the path around the orbit of this planet. I could be perturbing and could be maybe preventing other moons from forming there. It's definitely a possibility, of course. They found a goblin, says Graham. Yes, they nicknamed them a goblin. And usually researchers, when they found a new object, they just give the object a new nickname. And then many years later, after people everybody has agreed that there's actually a new object in existence, then they got it, and the International Astronomical Union gives them a new name. So there are different conventions, and then lately we would like to have different conventions that actually not only include the cultures of the Western civilization, but also we can use naming conventions from other cultures around the world. So 80 astronomical units is a long way around the sun. Yes, it's very, very far. And the period is about 40,000 years, so the orbit. And that's part of the reason why these type of objects are being so hard to find. That's why we haven't found Planet 9. It might be there, but it's very far away, it's very faint, and it's also gonna have maybe gonna take luck even to find it. Right now, is the goblin coming towards us or going away? Um, yeah, I don't know exactly what in the orbit the goblin is. So let me see in the paper if they mention it or not. Mm, I don't see anything right away in the abstract. I will have to look at the paper in more detail. They mentioned that the closest that it could get towards the sun is even 65 astronomical units. So they found it at 80 astronomical units, but it could be so yes, it could be moving away, or it could be moving closer. But the closest that it could be of the sun is about 65 astronomical units, which is still huge. That's the perihelion. Mm, Let me go back to the chat. That is quite an orbit. Yes, it's very, very elliptical, very elongated, and yeah, just gives more support to the existence of maybe another object that could be causing this type of alignments in this type of objects. It's not proof of the existence of Planet 9, but um, it helps with the case. So if the Exo Moon story pans out, we may find a lot of this, and since it would be easier to find larger exomoons rather than moon-sized, like our own moon. Yes, they're very difficult to find, but if they confirm it, of course, then people are going to be looking for them, and then there's going to be another data point of what the light curves should look like. A priori, of course, we could find something that is not like the moons that we observe in our own solar system. But definitely, the more planets we find and the more we look, we're going to be able to find more of these type of objects. So in the future, as I said, we have this transit method, but then actually using gravitational lensing, we're going to be able to find a lot of more exoplanets towards the center of the I'm sorry, towards the center of the galaxy. And then using, of course, artificial intelligence methods, machine learning methods, we really hope to be able to find more of these type of objects. But yeah, what we need is better facilities, better telescopes. What would be great, it would be a very large aperture telescope in space, like HAVEX or LUVOIR or something like that, and that could help us actually get an image of one of these exoplanets. Maybe not yet of the exomoons, but an exoplanet. That would be like the next goal and the next cool thing, to actually be able to image one of these planets. But for that, we need the technology. We need to put the budget into building these facilities in space. It's not cheap to build something in space, but a few weeks ago, there was a report commissioned by the National Academy of Sciences, where the experts in the exoplanet community said that we actually have the capability, if we invest the budget, we have the capability of building an observatory in a space that will allow us to image an exoplanet within the next 20 years or so. How do they know that the exomoon is not a partial ring? Um, I believe because of the size of the width of the light curve. Actually, I don't know exactly how it would be the interaction between the light of the host star with a ring. But the basic principle of the whole this thing is that you have this massive, maybe not solid, but this massive opaque object, a spherical object, large enough to be a sphere that is actually blocking the light of the host planet. And I would imagine that the reflection, the albedo, or the characteristics of a ring, for example, would give a different signature even if the ring was dense enough to be able to block light or to interact with the light. Could this moon be more like a binary planet system? Well, we call it a moon because of the ratio between the planet and the moon. As well, the mass of the moon is about 1.5 the mass of the host planet. So it's not that you have two objects that have comparable mass and size and actually revolving around each other around a common center of mass. These two objects are of course revolving around their common center of mass, but at this ratio of masses, I would expect the center of mass to be, of course, closer to the geometrical center of the larger body. So, so yeah. All right, everyone. It's already 30 minutes past the hour. Well, that was interesting. That was an interesting conversation. I'm sorry if the volume wasn't the best today. I'm gonna check, and hopefully tomorrow we will have a better volume in the sound. I'm gonna check what's going on because I brought the microphone today, but yeah, because tomorrow I will be here again. Dr. Pamela will still be here in Australia. Hopefully she will come back next week. But well, thank you so much for watching us. This has been the Daily Space, a production of CosmoQuest, and we really appreciate your help through likes and subscriptions. And every little bit helps. And hopefully, you guys enjoy the stories of today, and we will see each other again tomorrow. Bye bye, everyone. Have a good day.